Hello, in this video today, we are going to go through IXL assignment YZU, multiply numbers written in scientific notation. All right, let's just go ahead and get started here today. We are being asked on this first question to multiply a number written in standard form, so our 3, times a number written in scientific notation, so 3 and 10 to the 4th. When we have a mixed forms like this, that's okay. We can go ahead and still follow the same steps to multiplying as if they were both in scientific notation. And if you guys want a little reminder on that, I'm going to actually show IXL's Learn with Example because it has some great graphics and we'll talk through it. So when we have a number like that, our associative property of multiplication tells us that we can group those factors together in any which way. So therefore, we can group together our coefficients and multiply those, and then separately, we can group together any of the notation parts, so anything that has a base of 10, and use the properties of exponents to multiply those. We'll get into some more like that later on in this video, but that's just a quick little rationale as to why we can do that regrouping. That's because of the associative property of multiplication. All right, now let's go back and apply that to this example right here. So that is telling us that we can regroup this and we can multiply our number written in standard form, which is that first 3, and then the coefficient of the number written in scientific notation. That's our second 3. Well, 3 times 3 is 9. And then I don't have any other base 10s to multiply that 10 to the 4th by, so it's just going to stay times 10 to the 4th, which is this answer choice right here. That is our simplified version. That is our product when we multiply those two together. All right, some of these questions are going to be the same type, only instead of it being multiple choice, you're going to have to plug your answer in. So we'll go ahead and do this one as well, so we can make sure you know how to use those buttons in IXL. So we're being asked to multiply 2 times 5 and 10 to the 4th. And the directions tell us that we need to write our number in scientific notation. Well, let's go ahead and group together our coefficients, which would be our 2 and our 5, and we can multiply those. 2 times 5 is 10. And then I don't have any other numbers written in scientific notation that has a base of 10 for me to do that multiplication. So it just stays times 10 to the 4th. But uh-oh, I see a problem here. Do you guys see a problem? That number is not really written in proper scientific notation. Because in order for something to be in proper scientific notation, our coefficient has to be a number that is less than 10. And that is exactly 10, which means that's not allowed. But that's okay. You didn't do anything wrong. This is going to happen probably quite a bit throughout this activity because when you multiply, numbers get big really fast. So we just need to convert this. We just need to rewrite this so that way it's written in proper scientific notation. Well, currently, there is a decimal point right here after the 10. Just remember, if I don't have any numbers that fall to the right of my decimal point, there's no need for me to put it, so it's usually just invisible. But for our sake, we want to make it visible. If we want to rewrite this, we got to move that decimal point. So that way, instead of this being a 10, this number is less than 10. So it's going to move 1 space to the left. When I move that 1 space to the left, remember, that's what our exponent means in scientific notation, is there are 4 movements of that decimal point that need to occur if I wanted to change it back into standard form. So we're now adding an extra decimal point movement. So if we're adding one extra decimal point movement, that means we need to show that by adding to our exponent. So this becomes 1 times 10 to the 5th. That's definitely something to always pause and look for. When you finish a problem, make sure that it is in correct scientific notation, and you don't need to move that decimal point a couple places to ensure that your coefficient is a value less than 10. Now that we've done that, we can type our answer in. So we'll just use our keyboard to type in 1, and then right here we have our blue X. And then we want to do keyboard with a 10 and select this one, and that brings us into exponent mode. We can do our exponent of a 5. Oh, good. Now we have one where we're multiplying and both numbers are in scientific notation. So let's check this out. The beginning steps are still the same. I am still allowed, when I'm doing that multiplication, to use the associative property and regroup. So I want to multiply my two coefficients, which would be the 4 and the 2. So 4 times 2 is 8. Then I want to multiply my numbers with a base of 10. I'm going to write this up here so we can see it a little bit better. To do this multiplication, that's going to bring us back to our prior lessons on the properties of exponents. Remember, with the properties of exponents, if you are multiplying two powers with the same base, so our first power is 10 to the first, our second power is 10 to the second, do they have the same base? Yep, they both have a base of 10. That means we can use the product property, which tells us that we're going to add our exponents. So 1 plus 2 is 3. We have 8 and 10 to the third. Is this in correct scientific notation before I type it out? Yep, because my coefficient right here of an 8 is a value less than 10, so we don't need to move any decimal points and add any exponent values. We're good to go right there. 8 times 10 to the third. Perfect. All right, let's go ahead and jump up a notch and see if we can try a little bit harder of a question. This is a good one. So not only do we have larger numbers, but we also have a negative exponent. Now, let's go ahead and just take this one step at a time. We see that we're multiplying 60 times 5 and 10 to the negative 7th. Well, we're going to start off with multiplying our coefficients. So 60 and 5. If you're able to do that in your head, awesome. If not, then do multiplication on paper the long way. I'll go ahead and just give you a quick reminder on how to do that. So 60 times 5. Remember, when you set up that multiplication, you always put the number with more digits first, and then the number with less digits at the bottom. And this 5 then gets multiplied to first the 0. So 5 times 0 is 0. And then 5 times 6 is 30, which means 60 times 5 is 300. And we don't have any other numbers written in scientific notation. I don't have any other base 10s to multiply that 10 to the negative 7th to. So we'll just bring it on down. But first off, do any of the answers up top look like that? No, because I'm not done. That number is not written in proper scientific notation. In order for it to be in the correct version and the proper version of scientific notation, remember, our coefficient needs to be less than 10, and 300 is not less than 10. So once again, we're going to go to the very end of that number and Undo that invisible ink, make that decimal point obvious, and we need to see how many times do we need to move that decimal point so our coefficient becomes less than 10. If we move it once, our number goes from 300 to 30, but that's still not less than 10. So if I move it a second time and put it right here instead, we now have the number 3. So it went from 300 to 3. That is less than 10. But because I moved my decimal point 2 places, that affects my exponent, because in scientific notation only, that exponent refers to how many times that decimal point is moved. So if we moved it 2 places, we need to add the 2. -7 plus 2 would be -5. In this case, because we're dealing with scientific notation, that negative exponent is okay, because that negative has a very specific meaning. That tells us the direction that we have to move things if we're going and converting it back into standard form. That tells us that this is actually a really, really small decimal number if I'm going to convert it back. So this right here is our final simplified answer. All right. Let's jump it up again. Let's try another one. Oh, this is good. We now have some decimals involved. So some of these questions, you won't just be multiplying whole numbers, you'll be multiplying with decimals. But that's okay. You can do that. And if not, then it's a great opportunity for us to get that practice, because it is a very important skill for us to be able to do the multiplication with all types of numbers, whole, decimal, fraction, by hand. All right, first things first is always multiply your 2 coefficients. Oops, that was a bad circle. So we have the decimal 2/10 times 3. When we set this up for multiplication, we want to set the number with more digits up top. Well, even though 2/10 is smaller, that has more digits. It has a 0 and a 2. So that's going to go up top. And then yes, your 3 is technically a larger number, but that only has 1 digit. It's going to go down at the bottom. And remember, when you multiply numbers with decimals, you do not need to line up the decimal point. You line it up this way: the number with more digits on top, the number with less digits on the bottom. Let's go ahead and do that multiplication. 3 times 2 is 6. We're going to temporarily ignore the decimal point. 3 times 0 is 0. Now that we're all done, we're going to look at the decimal points. So in this first number, we have 1 digit that is to the right of our decimal point. In this second number, we have nothing to the right of our decimal point, meaning when we add this together, we need to move our decimal point up 1 unit. So there should be 1 number following our decimal point. So 0 and 6/10 times 10 to the second, because we didn't have any other powers of 10 that would cause us to need to multiply that. So it just stays 10 to the second. All right. Now, one thing that I'm realizing I forgot to clarify earlier is we had talked about how, in order for it to be in proper scientific notation, our coefficient here, so in this case, our 6/10, needed to be less than 10. Well, there's another restriction. It also has to be greater than or equal to 1. Is 6/10 greater than or equal to 1? No, that means, once again, I gotta rework this, so I need to move that decimal point so I can write this in proper scientific notation and have my answer. On the problems we did earlier, we always had larger numbers, so we needed to move that decimal point to the left to make it smaller to get it to be less than 10. Here we have the opposite. We have a number that's less than 10. We have a tiny number. So we need to move this decimal point to the right one space. And in doing so, it makes it 6. Well, remember in scientific notation only, that exponent represents how many times your decimal point was moved. Well, we just moved it backwards. We didn't go up 1, we went backwards 1, which means we are decreasing a decimal point movement. So if we're decreasing a decimal point movement, when we have to undo it and go to the right, we are losing a movement. So in this case, we have to subtract 1 decimal point movement. And 2 minus 1 would be 1, meaning this would be our final answer in proper form. So that is something that it's good to have in your notes, and you could always back the video up and have that where you have one example of if you're moving the decimal point to the right, you're adding to your exponent. Oops, sorry, I said that wrong. Forget that. If you're moving your decimal point to the left, you're adding a decimal point movement. If you're backing it up, if you're going to the right, you're decreasing, you're subtracting 1. All right, let's see if we want to do one more problem here. All right, these problems all look pretty similar. We just have larger decimal points here, but the process is pretty similar. So just make sure that you always are double checking where your decimal point goes. I think that's the trickiest thing about this is when you get done, ensure that your coefficient falls anywhere between 1 and less than 10. All right. Don't forget that if you want to see a few more examples, IXL has a little tutorial. Sometimes it helps to hear it from a different perspective, hear it from a different voice. So check that out. And then, of course, there's always the option of coming to help sessions and sending an email. So it is your turn to try. I know you can do this. Good luck.